factor the numerator and denominator of this rational function completely, and they're quadratic trinomials with leading coefficients of 1, so we'll use a crisscross to factor. We're looking for factors of -2 that add to equal 1, and those would be +2 and a -1. So the numerator factors as x plus 2 times the quantity x minus 1. Then the denominator, we're looking for factors of 2 that add to equal 3, which would be +2 and +1. So the denominator factors as x plus 2 times the quantity x plus 1. And we have common factors in the numerator and denominator of x plus 2. Those will cancel and create a hole in the graph. To find the coordinate of that hole, we take the canceled factor x plus 2 and we set that equal to 0. And x equals -2 would be the x coordinate of the hole. Then to find the y value that goes with it, we substitute that -2 into the simplified form of our rational function. So -2 minus 1 divided by the quantity -2 plus 1. And that would be a -3 over -1, which is a +3. So on our graph, we go over to -2 up 3, and we'll use an open circle for the hole. And then to find the y-intercept, we put 0 into the simplified form for all the x's, and that would be 0 minus 1 divided by 0 plus 1, which is -1. So 0, -1 is the y-intercept, and we put a closed circle there on the graph. To find the zeros, we take non-canceled factors from the numerator and set those equal to 0. So x minus 1 equals 0. We'll add 1 to both sides, and x equals +1 is our real 0. So we put a closed circle there on the graph at 1, 0. Then to find the horizontal asymptotes equation, if we remember Bobo Botten eats DC, that's our acronym for horizontal asymptotes. And the Botten, Bobo is bigger on bottom 0, y equals 0, bigger on top none, and you would look for oblique. Eats DC is exponents are the same divide coefficients. So since our exponents here are the same in the numerator and denominator, we divide the coefficients and we get a horizontal asymptote at y equals +1. And then our vertical asymptote comes from non-canceled factors in the denominator, and that would be an x plus 1. We set that equal to 0, subtract 1 from both sides, and x equals -1 is the vertical asymptote. So we sketch that on the graph. Then we need some extra guide points. So if we put in a -3 for the x into our simplified form, that's -3 minus 1 divided by -3 plus 1, which is -4 over -2, or +2. So we go to -3 up 2 and plot that point. Then if we put in a +3 for the x, we'll have 3 minus 1 over 3 plus 1, which is 1/2. And we'll go ahead and plot that point as well. And then we can see the shape of the hyperbola coming along this vertical asymptote, bending through those guide points and towards the horizontal asymptote. Okay, then for the other piece of the hyperbola coming along this horizontal asymptote, we bend through the guide point, hop over the hole since it's undefined there, and up towards the vertical asymptote. Okay, the domain is all x values starting at the left and heading to the right. So we're at negative infinity, and then we continue until we reach the x-coordinate of this hole at negative 2. Then a union, pick back up again at negative 2 on the other side of the hole, and we continue just a little bit over until we reach that vertical asymptote at negative 1. Hop over the vertical asymptote, and then we're headed off to positive infinity. Okay, the range is the y values going from bottom to top. So we're starting at negative infinity at the bottom of the y-axis, and then we rise until we reach y undefined at this horizontal asymptote at 1. Then we hop over the asymptote and continue on till we reach the y value of that hole, which is positive 3. Pick up at the hole and up to positive infinity.